Orbit was supposed to be out of bounds for warfare, but a single line in the 1967 Outer Space Treaty left a loophole. Nuclear weapons were banned and everything else was treated as fair game. The United States poured over $30 billion into the Star Wars program, only to walk away. Today, space is a military frontier again, and the idea of a weapon that could end all wars from above is no longer science fiction. But how did we let the final frontier become the next battleground? The Outer Space Treaty, signed in 1967 by the United States, the Soviet Union, and dozens of other nations, was meant to keep the most destructive weapons off the planet's doorstep. Article 4 spells out its core promise. No country may place in orbit any object carrying nuclear weapons or other weapons of mass destruction. It also forbids military bases and weapons testing on the moon and other celestial bodies. But the treaty's language stops there. It says nothing about conventional weapons, no mention of kinetic strikes, non-nuclear missiles, or directed energy systems. This silence is not accidental. Negotiators in the 1960s could agree to ban nuclear arms, but neither side wanted to forfeit the option of military satellites or future technologies they could not yet imagine. As a result, the treaty draws a sharp line. Weapons of mass destruction are prohibited, but everything else remains in a legal gray area. The definition of peaceful purposes is left vague, allowing reconnaissance, communications, and even potential dual-use military hardware to circle the globe. Legal scholars and government analysts agree the treaty's wording creates a loophole. Conventional weapons such as kinetic rods, lasers, and anti-satellite missiles are not banned as long as they do not carry nuclear or weapons of mass destruction payloads. This permissive framework has shaped every decision about space militarization since. The world's most powerful nations continue to interpret the treaty narrowly, keeping their options open while the law looks the other way. Ronald Reagan's Strategic Defense Initiative began with a promise: a shield in space that could make nuclear missiles obsolete. By 1983, the United States was pouring billions of dollars into research, hoping lasers, particle beams, and orbiting interceptors could stop a Soviet attack before it reached American soil. At its peak, SDY commanded more than $30 billion in funding, drawing in thousands of engineers and military planners. Lieutenant General James A. Abrahamson, the program's director, once told Congress, "We are pursuing technologies that could change the balance of power forever." But the reality behind the scenes was far less certain. Technical hurdles mounted. Interceptor satellites needed pinpoint accuracy, and lasers struggled to track targets through the atmosphere. Critics warned that each new breakthrough only pushed adversaries to find countermeasures or escalate their own efforts. By the early 1990s, the Cold War had ended, and the political appetite for a space-based shield faded. In 1993, the U.S. government shut down SDY after spending more than $30 billion with no operational system deployed. The legacy of SDY lingers today. Its vast budget and abrupt cancellation showed just how high the costs can climb when the race for dominance moves beyond Earth. The program's ambitions set a precedent for the scale and speed of military investment in orbit, and its collapse left a cautionary note. In space, even the grandest plans can vanish with a single stroke of a pen. On January 11, 2007, a Chinese missile struck the defunct Fengyun 1C weather satellite more than 850 kilometers above Earth. The explosion shattered the spacecraft into over 3,000 trackable fragments, each one now a bullet racing around the planet at nearly 8 kilometers per second. Most of these shards remain in orbit today, invisible to the naked eye, but deadly to anything in their path. Some will circle the Earth for decades before finally burning up in the atmosphere, but many will linger even longer, threatening satellites, space stations, and future missions. Mariba Jha, an orbital debris expert, warned that every new fragment multiplies the danger. Even a paint chip at these speeds can punch through metal. The risk of collision grows with every fragment, creating a crowded, unpredictable environment where a single impact could trigger a chain reaction. This is not a distant threat. The debris from Fengyun 1C still forces operators to maneuver satellites and astronauts to shelter in hardened modules. The scars of that single test remain etched into the crowded lanes of low Earth orbit. The United States Space Force now commands a budget topping $30 billion, channeling resources into surveillance, satellite defense, and rapid response capabilities. General Chance Saltzman, its current chief, argues that control of orbit is no longer optional. Everyday life depends on GPS, communications, and weather satellites that are now potential targets. The lines between civilian and military tools are blurring fast. On-orbit servicing satellites, originally designed to refuel or repair, can also grapple and disable enemy assets. Brian Whedon, a policy expert, warns that these dual-use technologies make intent nearly impossible to verify, fueling distrust among rivals. Project Thor, once a science fiction concept, is now technically feasible. Dropping a tungsten rod from orbit delivers the force of a small nuclear blast, up to 11 tons of TNT without radiation or a launch warning. Just one Starship-class rocket can loft over 100 metric tons into orbit, enough to deploy dozens of these rods in a single flight. Directed energy systems and electromagnetic pulse weapons, known as EMP, add new layers of threat, with lasers capable of blinding satellite sensors and EMP attacks able to fry electronics across continents. Each advance widens the spectrum of what counts as a weapon in space, expanding the challenge for policymakers and commanders alike. In August 2021, a Chinese rocket launched a new kind of threat into orbit, a hypersonic glide vehicle riding a fractional orbital bombardment system. Unlike traditional intercontinental missiles, this weapon circled the planet before diving toward its target, traveling at speeds that outpace most missile defenses. U.S. intelligence tracked the partial orbit, noting the weapon's unpredictable trajectory and the challenge it posed to early warning systems. 3 months later, Russia fired a direct ascent anti-satellite missile, shattering an old Soviet satellite. The debris forced the International Space Station's 7-person crew to shelter in their escape vehicles for 33 tense minutes. NASA's ground controllers ordered power downs and constant trajectory checks as fragments zipped past within 40 kilometers, underscoring how a single test can threaten lives in orbit. Meanwhile, new launch vehicles are rewriting the limits of military logistics. SpaceX's Starship, capable of delivering over 100 metric tons to low Earth orbit in a single flight, now gives any nation with access the means to deploy massive payloads, whether satellites, kinetic weapons, or entire constellations on short notice. The combination of unpredictable attack profiles and rapid launch capacity is reshaping the risks in orbit, making space a domain where escalation can happen with little warning. A single collision in low Earth orbit can set off a chain reaction, each impact spawning thousands of new fragments. This is the Kessler syndrome, a runaway cascade that could fill the most valuable orbital lanes with debris, making them impassable for decades or even centuries. The threat is not limited to astronauts or space agencies. Every GPS signal, international bank transfer, and weather forecast depends on satellites vulnerable to these collisions. The global space economy now supports more than $1 trillion in annual activity, with essential services woven into daily life. If a cascade takes hold, not only could future missions be grounded, but trillions in civilian infrastructure could be lost. Commercial satellites, navigation, and emergency systems would go dark, and the world's reliance on orbit would become its greatest risk. The stakes are no longer theoretical. They are measured in economic survival. A global moratorium on debris-generating anti-satellite tests now stands as the simplest, most enforceable step. The United Nations General Assembly adopted a resolution in 2022 with overwhelming support. 155 nations voted in favor, but China and Russia opposed the resolution, wary of limiting their own options. Satellite tracking networks already monitor launches and debris, making compliance straightforward. Commercial operators and policy experts argue for mandatory transponders on large satellites and on-orbit servicers, boosting transparency and reducing the risk of miscalculation. The Artemis Accords, with 55 signatory countries, promote peaceful space use and data sharing, yet the world's two largest rivals remain outside the framework. Arms control specialists and retired military officials push for a new protocol to the Outer Space Treaty, banning kinetic and directed energy weapons in orbit. Each proposal faces hurdles, cost, verification, and political buy-in, but the tools exist. What is missing is the collective will to act before the next disaster. Today, whoever controls orbit controls the world below. With over 3,000 new pieces of debris from a single test and with military budgets soaring, the line between defense and catastrophe grows thin. The future of peace may depend on decisions made in silence, high above our heads.